NASA is set to make a big announcement today. It is using a new technique to reveal the mystery behind the origin of sunspots. It is a process called sound speed mapping. That's when scientists analyze sound waves ricocheting inside the sun. Using this technique, a team of Stanford scientists have created the first detailed image of the inner core of a sunspot.
The scientists use a device called the Michelson Doppler Imager, or MDI, to create those images you were looking at. And with more on that, here is Tech Live's Bob Hirschfeld.
Sunspots have been a mystery since Chinese astronomers first reported them in the 4th century BC. In recent years, researchers have determined that sunspots appear to increase and decrease in number in cycles that last about 11 years. And they're linked to solar flares that shoot out violently from the sun's surface, ejecting massive amounts of charged magnetic particles, powerful enough to disrupt satellite communications here on Earth. The latest findings are the result of observations from NASA's SOHO spacecraft, the Solar and Heliospheric Observatory. On board is an instrument called the Michelson Doppler Imager, or MDI. Chief scientist for MDI is Alan Teitel.
This is the front end. This is a door that opens up, which would uncover the lens of the telescope. So there's a little telescope here. It's about 6 inches in diameter. Inside is a fairly sophisticated set of optical filters that allow us to isolate individual spectral lines and to measure the shift of those lines. And back here, this white plate is the radiator, the cooler, for a 1,000 by 1,000 CCD camera, which is the data collection system for MDI.
The images from MDI are stunning. They reveal that sunspots resemble giant vortexes that suck electrically charged gases from the surface of the sun down into the interior. Furthermore, the sunspots are born in pairs. Each pair is a magnetic opposite some distance apart.
For about 11 years, all the sunspots in the northern hemisphere have their leading polarity positive, and in the negative hemisphere they have their negative polarity, their leading polarity is negative. And this goes on, as I say, for about 11 years, and then the magnetic field of the sunspot reverses, fields reverse of the whole sun, and the new sunspots in the new cycle have the leading polarity in the opposite sense.
The MDI instrument has given scientists their first look below the surface of the sun at what happens directly below the sunspots. It appears that as the gases are drawn into the sunspots, they're cooled. But as they are pulled further down into the sun's interior, the gases heat up again, and at the very root of the sunspot can exceed the temperatures of their surroundings. At this point, it's still unclear exactly what's going on. But scientists say unraveling the process will be a key step in understanding how stars form and ultimately how the universe evolves.